The model of a basic computer is known as the three-box model. The three boxes are the central processing unit, the memory, and the input and output. Early modern computing started in 1822 when Charles Babbage created a machine. It calculated numbers from given inputs. However, he never got to complete his plans because he didn't have enough funding. John von Neumann is the man behind the von Neumann architecture. He is a mathematician and an early computer scientist. His model has a single storage system for storing data as well as a program to be executed. This is a relatively older architecture and was replaced by the Harvard architecture.
Processor, or CPU, is one of the most complex parts of any computer system. The processor executes programs and supervises the operation of the rest of the system. Most modern processors contain billions of transistors. Multi-core microprocessors are now very popular, where the processor will have several cores, allowing for multiple programs or threads to be run at once.
Main memory is used to store program instructions and data, using the system bus to communicate with the CPU. Main memory is often created using random access memory, RAM, or read-only memory, ROM. Modern computers will have gigabytes of RAM, meaning that large programs can run and multiple programs can run at once. The more main memory that you have, the larger the number of programs you can run at once.
An I/O controller is an electronic circuit that connects to a system bus and an input/output device. It provides the correct voltage and current to the system bus and the input/output device. Examples would include keyboard controller, disk controller for a hard disk, video display controller. The von Neumann is a relatively older architecture and has been replaced by the Harvard architecture. Whereas the von Neumann has single storage memory for storing data as well as a program to be executed, the Harvard has two separate memories for storing data and program. The von Neumann processor needs two clock cycles to complete an instruction. Pipelining instructions is not possible with this architecture, whereas the Harvard processor can complete an instruction in one cycle if appropriate pipelining strategies are implemented.